This is a really short section just connecting thermochemistry to like your diet and stuff. But you should understand that thermochemistry, you are essentially the little engine and you run on fuel. So obviously when we talk about calories and stuff, you're talking about how much fuel does it provide your body. And again, when we say something has a fuel value, obviously, heat is being released when you burn your food, but they say it's a positive even though it is exothermic. So most of our energy comes from carbohydrates and fats, and again, we usually use carbohydrates, we usually use starch, and again, we break it down into glucose, and we get our blood sugar. Our bodies can't handle a lot of carbohydrates, which is why we store things as fat. We can't adequately store things as carbohydrates. But it's nice, carbohydrates are good because you can easily react glucose very simply, and you've all seen this reaction before, and you get lots of energy. So again, why do you carb load when you want to do really well in a sporting event sometimes? Because your body's very efficient at breaking down the carbohydrates. Again, our body's not very good at storing carbohydrates. We store very little carbohydrates. So if your body needs to store energy, it's going to store it as fat, which is awesome for us. And again, one nice thing about fats is they're not water soluble. So it's a very efficient storage system because it's not like your fats just randomly break down or anything. This is a tristerin, this is a normal fat product, and you can see that when fats break down, you get massive amounts of energy, which is just crazy. Which is why, unfortunately, if you have some fat and you would like to lose it, it is really hard to lose fat because you have a lot of energy to burn to get rid of some fat here. So you better start running now, I guess. 2 reasons we said, again, fats are stored. They're insoluble in water so that we can very efficiently store them, and they give you more energy than the carbohydrates. Your body does use protein, and you need protein, but that's typically to build your body, so your muscles, your skin, your hair, all that kind of stuff. And again, proteins have a lot of nitrogen in them, and if you've ever smelled, nitrogens are typically in amines and stuff, and if you've ever smelled an amine, it's when things decay. So think of like rotting fish or decaying flesh. So not the nicest things in the world. If there's excess nitrogen, it typically just comes out of your urine, and that's a major component of urine is urea, which is interestingly also one of the things we use when we do tie-dye. So I'll leave you with that thought for a little bit. And then just one little last thing here. Obviously we use fuels, and you can see that unfortunately this was a while ago, but although we only are less than 5% of the population, we're even less than that now, we still consume more than a quarter of it. And you can see we're not very good at a lot of different things, so they're still working on it and all that stuff. But be aware that thermochemistry is a very relevant topic, and you can be a thermochemist in a lot of different areas. If you want to work on renewable energy, you can be a thermochemist. If you want to work for the oil companies, you can be a thermochemist. If you want to be a nutritionist, still thermochemistry applies to you.